I welcome you all to the session of engine system and performance, and in today's class we shall discuss about the design aspects of several components, particularly several valves and engine block, and then we also shall discuss about the cylinder arrangements, and finally we shall discuss about the material or materials used to construct several components of engine. So, to start with, let us discuss about the design aspects of valves, rather constructional features of valves typically used in engine. So, if we write here that constructional features of valves, we had seen that valves are used, typically we had seen intake and exhaust valves. These two valves are very important to control the flow of incoming air and also the combustion gases. Timely flow or timely intake of fresh air or charge and also timely expelling out all the combustion gases from the cylinder is very important for an efficient operation of engine. So, valves play an important role to control the flow of incoming air as well as leaving of combustion gases from engine cylinder. So, if we draw the constructional feature of the valves in several arrangements, one is known as valves in block. So, case A, when valves valve is in block of the engine. So, if we draw here, so this is the valve, so this is, I should draw even more. So, this is the valve. You can see the valve is placed in the block itself, and this type is known as flat head or L head engine. This is L head or sometimes called as flat head engine. Okay. So, that means what we have understood is that valve is placed in the block itself, not in the head. If the valve is placed in the head, then if we draw second type, and if this is the valve, so this is the valve, and you can see the valve is placed in the head of the block or head of the engine, and this type of engine is known as I head engine. So, valve is placed in head and this is known as I head engine. Okay. So, you can see just we could classify engines again depending on the constructional feature of the valve. So, firstly we had seen the type of L head engine wherein valve is placed in the block itself, Now, we can see this type of engine is known as I head engine, wherein the valve is placed in the head itself. We also can classify another type. If we draw that, maybe depending on the requirement of the engine, so this is the valve 2, and also one valve will be there here. So, this is valve 1. So, we can see that in this particular type, there are two valves, one valve is in the head and other is in the block, and this type of engine is known as F head engine. So, one valve is in block and other is in head. This type of engine is known as as I told you, F head engine. And so, what we had seen, valve can be placed in the head, valve can be placed in the block, valves can be placed both in head and in the block. We also can have another one type wherein, so this is C, type C, and we can have finally D. So, let us draw the constructional feature, then we shall discuss about this particular type of valve or this particular type of engine. So, we can have so this type of engine, you can see that both valves are placed in the block, and this type of engine is known as T head engine. So, I am writing here both valves are placed in the block, and this type of engine is known as T head engine. So, we had seen based on the constructional feature of the valve arrangement, we could classify engine into 4 different categories, that is F head, L head, T head and I head. Now, let us look into the arrangement of the cylinder. So, if we go to the next slide, that means until now we have discussed about engine classification or arrangement of different arrangement of valve or valves, and then based on that arrangement we could classify engine also in 4 different categories. Now, we also can have different arrangements of engine cylinder. So, let us now discuss that particular part, that is cylinder arrangements. Okay. So, that like the classification of engine based on the constructional feature of valve or valves, we also can classify engine based on the cylinder arrangements. So, the first type is very simple, that is called single cylinder engine. I should say single cylinder arrangement. So, let us draw the schematic depiction of this particular type. Very straightforward. So, we will be having valve here and so this is crank and connecting rod mechanism. So, you can see that single cylinder and piston is there, and piston will reciprocate between two identified locations, that is top dead center and bottom dead center. So, engine has single cylinder and piston is connected to crank and crankshaft, or I should say crankshaft. So, piston is connected to crankshaft. So, this is the most simple type of cylinder arrangement. Then let us discuss about most common type, that is most common type in most of the automobiles. So, this is B, most common type arrangement of engine cylinder. So, let us draw that one. And all these so this is the most common type arrangement, and this is called inline, it is called inline arrangement. So, if I write here, this is called inline cylinder arrangement. So, here you can see that just I could draw only 4 different cylinders, wherein what you can see, cylinders are positioned in a straight line, one behind other along the length of the crankshaft. Cylinders are positioned in a straight line, one behind other along the length of the crankshaft. So, this is the crankshaft which is rotating. So, this is the crankshaft, and so cylinders are arranged along the line or in a straight line, one behind other along the length of the crankshaft. This type of arrangement is most common in automobiles. Typically, 4 to 6, or depending upon the requirement 4 to 8 cylinders can be used. So, depending upon the power requirement, number of cylinders to be used in line should be designed or selected, and I am writing here this inline arrangement arrangements are common in most of the automobile. In automobiles and other applications. I would like to mention here that engines are not only used in automobiles, there are many other places or there are many other applications like ship, aircraft, power plant or different industries engines are used. So, this most common type, that is inline arrangement or arrangements, are common in automobiles and other applications. Depending on the requirement of the power output, we can have 4 to 8 cylinders. Okay. So, this is B type. If we go for next type, that is called V type arrangement. So, this is C. So, we are mainly talking about this particular arrangement, that is cylinder arrangement. So, let us now draw schematically So, this angle is theta. So, you can see that shape is V type or V like, and we have common crankshaft. So, this is common. Common crankshaft, and this angle theta is basically 15 to 120 degree, right. It can vary 15 to 120 degree, but common is 60 to 90 degree. This angle can vary. What we can see, that two cylinders are connected to a common shaft. So, we will be getting power output from these two cylinders or two arrangements, and we can drive one common crankshaft. Okay. So, this is common in luxury and high performance vehicle. So, just I am writing commonly used in luxury and high performance vehicle. Okay. So, next let us look at another type, that is opposed cylinder type, D. opposed cylinder arrangement. Let us draw the schematic depiction of this particular type, then we will discuss about the working principle. So, you can see that one common crankshaft, okay, and so basically there are two cylinders that we can see as if they are opposing each other, right. Each cylinder is having one piston, and these two pistons are now connected to a common crankshaft, okay, and this is often known as flat engine. So, also known as flat engine, and typically used in small aircraft, used in some automobiles and small aircraft. So, this is opposed cylinder type or opposed cylinder arrangement. Now, let us look into opposed piston arrangement. So, again we have to draw the schematic depiction, then we can discuss about the working principle. So, if we draw so, this is, you can see, this is opposed piston type, as if the pistons are opposing each other. Now, in this particular type, the speciality is combustion chamber is the center between two pistons. So, this is the combustion chamber. So, this is the combustion chamber. Combustion chamber is the center between two pistons, okay. And it is very important, since there is a single combustion chamber, certainly power stroke will be executed by both the piston at a time. So, this is the important aspect of this particular type of arrangement. So, let me write here, if I write, since there is a common combustion chamber, right, both are executing power and exhaust stroke at same time. So, both cylinders or piston, rather it should be pistons, you know, will execute power and exhaust stroke at same time. So, this is very important, but still this particular type of arrangement has two different crankshaft. So, this is crankshaft 2 and this is crankshaft 1. Still there are two different crankshafts, but we could see only one combustion chamber, that is the common combustion chamber, and since there is a single combustion chamber, both pistons will execute power and exhaust strokes, you know, at same time. Okay. And this is used, I mean I shall write here, used for power plants, ships and submarines. So, this is the application, right. This is very important that this particular type is used for power plants, ships and submarines. As I said you few minutes back, engines are not only used in automobiles, but still engines are used in many other applications or many other places. So, this is the opposed pistons type. So, another important is that two pistons, there are two pistons that we can see in a single cylinder. So, two pistons in each cylinder. So, if we have multiple cylinders, then each cylinder will be having two pistons and as if pistons are opposing each other. Okay. Now, let us look into next type, that is called W engine or W type arrangement. W type arrangement. So, again we have to draw the schematic depiction to understand the operational principle. So, again this is sort of extension of V type. So, if we draw the schematic depiction of this particular type, again there will be common crankshaft, okay, and so this is looks like W type, and this is basically engine of 3 different cylinder arrangements. While connecting rods are connected to a common shaft, right. So, 3 cylinders all connecting rods are connected to the same shaft. Though we had seen this particular type, we are going to discuss, or we are discussing this particular type, this is not very common. So, this type is not common though, but some racing cars and luxury cars of late 90s had this type of engine. So, this is very important. Okay. So, that means we have discussed about W type arrangement. In this arrangement, we can see from the schematic depiction that 3 cylinders are connected to a common shaft. Certainly, 3 connecting rods are connected to the common shaft, and this type of is not common though, but still some racing cars and luxury cars of late 90s had this type of arrangement or engine cylinder arrangements. Okay. So, now let us discuss about the final type, that is radial type arrangement. So, radial arrangement, we can draw the schematic depiction first and then we can discuss. Okay. So, this is the schematic depiction of radial cylinder arrangement. We can see from the schematic depiction that there are 8 cylinders and all connecting rods are connected to the common crank that you can see. So, that is the common crank. So, this radial flow engine, what we can see from this depiction, with piston pistons positioned in a circular plane. Though I could not draw all these cylinders at per scale, but all these cylinders, all these pistons are positioned in circular plane, as if so you know that you can see now. So, this connecting rod is connected to this common shaft. So, all these are in a circular plane, and the common plane and the connecting rods of the piston are connected to of the pistons are connected to a master rod that I had shown over here by this circled field circle. So, all connecting rods are connected to a master rod, which in turn is connected to the common crank, which in turn is connected to a common crankshaft, I should write. So, this is the radial flow arrangement. Now, what about the application? So, typically you know that in radial flow arrangement, typically this is not always a case, but a bank of cylinder, or I should say a bank of cylinder, because you know that there are 8 cylinders. So, a bank of cylinders in radial flow arrangement, but before using the word always, I should say almost always has odd number of cylinders. So, this is very important that a bank of cylinders. So, this is the bank of cylinders 1, 2, 3, 4, 5, 6, 7, 8. So, if I start counting from here 1, 2, 3, 4, 5, 6, 7, 8. So, bank of cylinders in radial flow arrangement not always, but almost always has a odd number of cylinders. So, this is not always, that is why I have used almost always. From the schematic depiction you can see there are 8 cylinders, but it is not a case. So, typically the bank of cylinders for this particular type of arrangement has an odd number of cylinders. So, application if we write here, application is large ship and aircraft engine. So, used in large ships and aircraft engine. What is the reason behind this? We can see that in this particular arrangement we can see there are 8 cylinders. It is not always a case that there will be only 8 cylinders, it can have even 16 cylinders, 20 cylinders, even 30 cylinders. But as I said, typically for this type of arrangement the bank of cylinders has an odd number of cylinders. Since there are many cylinders, so power output will be more. Since the power output will be more, we can use this particular arrangement in place or in places where we really need high power or high work output, that is large ships and aircraft engines. So, to summarize today's discussion, we have discussed about constructional feature of engine, focusing on valve arrangement and finally the cylinder arrangements. And we had seen based on the arrangement of or constructional feature of valve and also the cylinders, we could classify engines into several categories. So, with this I stop here today and we shall continue our discussion in the next class. Thank you.